So let's get started here.
All right. Good morning, good afternoon, good evening, everyone. Thank you for joining our session today. This is both Red Hat and Twistlock, and we're going to be talking today about container deployment and security best practices. We know that the number of our clients, our customers, are deploying more so containerized applications, leveraging microservices, spreading with Kubernetes and so forth. We're here to talk to you today about some best practices and some guidance on how to leverage the best of both Red Hat and Twistlock as you go about containerized applications and deploying those in a very secure way. Next slide. With me today are two speakers that are going to take you through the best practices around containerization, around the leveraging of those technologies, and describe to you how they reference the NIST security guide for best practices. Today with us is John Morello. He's the Chief Technology Officer of Twistlock. And with us also is Dirk Herrmann, who is the product manager for both OpenShift and Play. Next slide, please. Today, we'd like to cover a couple things in our conversation with you. So one is, what is the NIST Special Publications Guide? We're going to talk a bit about how that was originated and its influence in the container market today relative to security concerns. The SP 800-190 guide is a document that contains all of the relevant information on how you can deploy containers in a very secure manner. Both Red Hat and Twistlock will talk about the content that we have, the resources we have, the platforms that we have to achieve those recommendations, and we'll have time at the very end for takeaways and questions and answers. We'd like to make this open to you throughout the conversation, so if you do have questions, please be sure to insert those into the chat box. We'll be monitoring the call throughout to be able to answer those questions as we go through the content today. So with that, why don't we go to the next slide? And I'll hand off to John Morello from Twistlock on the why and what of NIST.
Thanks, John. My name is John Morello. As John mentioned, I'm the CTO for Twistlock. I'm also one of the lead authors for the NIST Special Publication. So 800-190, we worked on for quite a while. Myself, some folks from Cisco and Intel, obviously Marusha Sapaya, who's a computer scientist at NIST, who led a lot of the efforts. But this was a very large effort that included multiple rounds of public comment and incorporation of feedback from lots of different organizations, including customers like Motorola and Department of Homeland Security, the U.S. Army, vendors like Docker, and some folks from Red Hat participated in this as well. And so the output of it is a guide, a special publication that fits in with the other special publications and the SP 800 series of cybersecurity special publications that NIST has put out, and takes the same basic approach to those that other NIST special pubs have, which is to say specifically that these special pubs are created anytime there's a major new shift in technology. So it's not like a special publication is created for kind of a minor enhancement or even a new product area, but really for kind of generational changes in computing. So as an example, there was NIST special publications that came out when virtualization became very popular, 10 or 12 years ago. There was another series of special publications that was released when cloud first became prominent. And now with this wave of cloud native and containers, this is the purpose of this new SP 800-190, is to define what the framework is for securing and protecting applications and infrastructure that you run to support these containerized applications and microservices. A NIST special publication is explicitly designed to be a vendor agnostic, basically roadmap, an overview of the space, not to tell you explicitly how to configure settings in a given product or implementation. So when you look at the special publication, it's intentionally not telling you instructions for how do you configure OpenShift or how do you configure Docker. There may be some examples in the special publication where we utilize vendor products such as OpenShift or CoreOS as an example to illustrate a concept or to be an example of a solution. But the special pubs are not designed to be something that gives explicit configuration guidance for those vendor products or specific projects, specific implementations of the concept. Instead, the special pubs are designed to outline the major kind of high-level recommendations, the way to think about security best practices for this technology wave, the way to think about the threats and countermeasures that are associated with them. And then there can be subsequent documents. NIST releases them called interagency reports that go into more detail about a specific vendor's implementation and how that vendor's implementation should be configured. And so there's some of those I know that have been worked on and are being currently worked on in this space as well. And the special publication is kind of the overall guiding document that those other interagency reports and even vendor recommendations down the line that might be issued by Red Hat or Microsoft or Oracle or someone would try to align with this special publication. And finally, we want to note that the special publication is not designed exclusively for government use, not designed explicitly for customers in the United States. While it was created by a U.S. federal government agency, the purpose of NIST is not just to serve the federal government. The purpose is to create guidance and awareness that can be utilized by all organizations and even individuals, not even just in the United States, but internationally. The National Institutes of Standards and Technology, NIST, is a part of the Department of Commerce. So, as you can imagine, as part of the Department of Commerce, one of the fundamental goals with these guides is to allow organizations to utilize these technologies in a safe and secure way for the promulgation of commerce and conduct of commerce. So don't think of this as just government-specific information. Although there will be government guidance that will be created based on this, again, this is designed to be vendor agnostic and high level such that it's not specific to one industry or vertical. So if you can go to the next slide, please. Let's talk now a little bit more about what the guide actually gets into and what are the kinds of questions that go into it and how do we address in the guide the way to think about this space. So if you further go to the next slide, we call out in the special publication a few things that are new challenges when you think about securing containers. This is not to say that containers are an insecure technology or that containers are higher risk than traditional patterns or anything that implies any kind of like fundamental problems with containers. But because containers are a new technology, like any new technology, there's different risks and mitigations that are associated with them. And so the beginning of the special publication, we call out what those are so that you can understand how this is different than traditional security systems or traditional security patterns for systems like virtual machines or just standalone server operating systems. So there's obviously a lot of technical differences between containers and previous generations of computing, but there's a few things that are really specific around security that are fundamental and not like a technical implementation detail, but just fundamental to the way that you utilize containers in your organization. One of those is that containers scale up and down far more frequently than traditional systems typically do. So, in the past, you might have had a model where you would deploy a new version of your application quarterly or maybe just annually or maybe not even that frequently. But it was pretty rare for people to be updating the application more than every few months. Whereas one of the driving factors that leads people to use containers is the ability to update their applications much more frequently. And that frequent update cycle changes some aspects of security because you can no longer rely on having this pretty long-lived baseline about how the application should behave. If you're using containers, you're probably building and shipping new versions of your app maybe weekly or daily, or some cases, maybe even multiple times a day. You can't rely on solutions and approaches that assume that a human operator is going to be part of every one of those deployment paths, making manual decisions about statically configured security policies. Secondly, the scale of the environment is much larger than you typically have had in previous patterns by the number of entities. So if you think about your traditional kind of n-tiered application, if you ran a kind of a simple web-based app in virtual machines, perhaps you might have 6 VMs that would compose that, maybe a couple front-end nodes, a couple of application tier nodes, and then a couple of back-end database nodes. And the entire application would be encapsulated within those 6 virtual machines. One of the fundamental concepts with containerization is to decompose the application and to tear apart the functionality into many more microservices that can be iterated on and updated much more independently of each other, and it can be scaled and managed independently of each other. And that's a fundamentally good thing from an application agility standpoint and your ability to scale your application more efficiently. However, from a security standpoint, it's also greatly increasing the number of entities that you have to manage and deal with. So instead of just simply having, those 6 virtual machines that I mentioned in my example, if you decompose that and run that in containers, perhaps now you might have 10 different microservices on the front end and 8 or 10 different microservices in the application tier. And so the number of entities that you have, in addition to them changing more quickly, is just a larger count to begin with. And so the fundamental guidance that we give people, if you go to the next slide, is that if you're dealing with the struggle of managing just a lot of virtual machines already, the more difficult challenge you'll have with containers is dealing with the scale and the rapid rate of change of containers relative to those VMs. And if you're already having problems just keeping up from a security standpoint with your virtual machines, you have to fundamentally shift the way that you're doing security to really be able to take advantage of containers in a secure way. You can't assume that there's going to be manual effort creating static policies as part of your security regimen. You've got to have something that's going to be more automated, something that takes into account more of the underlying capabilities of the platform to look at what's normal and find what's abnormal, and it doesn't rely on human interaction to be able to do the configuration of the security policies or the tooling that executes on those policies. If you skip to the next slide, the special pub, we tried to organize the special pub with this notion of threats and countermeasures. So if you look at the document, the beginning of the document goes through just an architectural overview. What are the different components that are involved in it? How do those components roughly relate to traditional patterns using virtual machines? Kind of define what registries and orchestrators and so forth are. And then the majority, the balance of that document is a risk analysis and a set of recommended countermeasures for those risks. And we organize those risks around these 5 areas, which are kind of the big building blocks of any container-related or container runtime environment. You have the images, you have your registry where those images are stored, you have your orchestrator like OpenShift, of course, you have your containers, so the actual runtime entities that are executing the software that's in those images, and then you have the host operating systems on which those actual images and containers are being run. And there's risks and things to consider at each layer of that stack. And if you look at the way that we built the special publication, it's really built around that combination or that thought process of organizing risks and countermeasures in those 5 areas. So if you move on to the next slide. We make a number of recommendations about the risk to consider and the countermeasures to apply to those, but I'm going to go through each one of them with some brevity here so we can get through all the content. I definitely would encourage you to look at the special publication for more investigation of the actual underlying risks and the kind of threat profiling and modeling that we did to come to that. But to talk about some of the countermeasures, from an image standpoint, one of the recommendations that we think is most important is that you have tooling that is aware of containers and images and is able to look at those containers and images throughout their life cycle. So the traditional mechanisms for doing vulnerability management often were a reactive approach. You would deploy your application or deploy your virtual machine, and then you would scan it for vulnerabilities after it had been deployed. What we're saying and what containers really give you an opportunity to do properly for the first time is to be able to secure that earlier in the life cycle. So the very beginning of the life cycle of that application, you're able to find vulnerabilities and to enforce those vulnerability policies from the very start of the life cycle throughout the time that it's actually deployed. The next part that we talk about is to make sure that you're using images that are trustworthy. So much as in the traditional world, you wouldn't want to be running software from unknown sources. Similarly, with containers, you don't want to be running upstream images that you don't really have validation of and that you don't trust. And that may seem like an obvious thing, but one of the things that makes containers so attractive to people is that it's very easy to reuse software that's already out there. And so the whole ecosystem makes it very simple for you to just say Docker run whatever, and to have that image automatically pulled and executed within your environment. And while that can be very handy from a development standpoint and save you some time, those approaches can introduce software that you don't know, that you don't have any control or provenance over into your environment. And so you really want to make sure that the images that you're using are trustworthy images that you've vetted, not just for the compliance and security and vulnerability aspects of it, but to make sure that those images are behaving in the manner that you expect them to. The next section we have is on registries. Registries are obviously the place where you're going to be storing those images prior to them running, but there's a few things that are specifically recommended for dealing with registries, or to think about the threats that exist specifically to the registries. One obvious one is making sure that you're requiring authentication and that you've got a proper role-based access control model for controlling what information or what images actually make it into the registry in the first place. Defaults in some implementations within this ecosystem assume that registries are just read-writable by anonymous users. Taking a very basic and obvious step to only allow certain people to push to your registry is a really necessary first step. But beyond that, one of the things that you really need to ensure is that you're not allowing your infrastructure to run applications from registries using an insecure connection. So, you're not going to have the ability to have end-to-end security and know that the images that you're running within your environment have not been tampered with unless the connection between the registry and the node is protected. So many of the applications and many of the implementations within this space do that by default, but it's important to ensure that you've got that TLS connectivity so that you're not only in protecting the data as you transition across whatever cloud or maybe internet environment you're using, and you may have confidential source code information in those images, but also to provide an additional guarantee against tampering of those images in flight. And finally, that registries, like any other storage system, can accumulate a lot of cruft, for lack of a better term, in them over time. You might have images that you haven't used in months or years that are still there. And if you're using a good tagging and naming process for your images, you can avoid accidentally using older images, but there's also not a lot of value necessarily in keeping those things around. And to reduce the risk, one of the things that we recommend doing is to identify those images that are stale or not compliant or should no longer be used, and pull them out of the registry or tag them in such a way where there's no possibility for them to be accidentally deployed as part of an application. The next pane we have is talking about Orchestrator Countermeasures. So by Orchestrator, we're talking about the technologies like OpenShift or Docker Swarm or Kubernetes itself that are designed to provide you the ability to treat a large number of individual compute nodes as kind of a general pool of capacity. And the orchestrators like OpenShift are what's responsible for load balancing and deployment and monitoring uptime and scale and so forth. And because of this, they're basically a privileged operator. They are the management plane for your environment. And so it becomes very important for you to be able to ensure security of that, because if you have an insecure orchestrator configuration, you can literally make the entire environment insecure because it has such privileged access to each one of the nodes that's part of that environment. So one of the things that we recommend here that again seems like an obvious notion, and is something that's been in many previous NIST special publications, is to make sure that you've got a least privilege access model to managing that orchestrator. If someone simply needs to be able to push some images to the registry, they shouldn't have an administrative level of access within the orchestrator where they can choose to run arbitrary code or arbitrary images throughout the environment. You should make sure that the access to the orchestrator reflects the actual business needs of a given user within that environment. One of the things that's often talked about, or that I often talk to customers that have questions about at least, is those second two bullets there about separating network traffic and really just generally workload isolation. One of the things that people sometimes are concerned about is the notion of the compromised neighbor. For example, like if I have a scenario in which I'm running some application workload that gets compromised, I want to make sure that application that's been compromised is not able to go and impact other aspects of my environment that are not maybe exposed to the same risk, but are still running on the same infrastructure. So one extreme mechanism you could use to do that, of course, would be to establish like separate environments for each one of your applications. That wouldn't really be very conducive or efficient, though, because you'd end up with such a large amount of overhead, it would be impractical to really make use of containers. At the same time, you don't want to have a model in which you've got your front-end containers running on the same compute nodes that are exposed directly to the internet as the containers that are maybe running your most sensitive applications that deal with like health information or financial details. So what we recommend in the special publication is more of a sensitivity level zoning of resources. So you may have an environment where you have a single cluster and you use node affinities to ensure that workloads that you consider to be highly sensitive all run within the same set of compute nodes, and workloads you consider to be less sensitive run in a different set of compute nodes. Or you might take more of a federated environment where you may actually have individual clusters. One cluster that's for high sensitivity, a different one for lower sensitivity, a third one for medium, and so forth. And to federate those, with a single management pane of glass and a common way of operating and configuring those environments. There's not a particular pattern that's a must-do for everyone. The must-do, and the thing that you're really trying to ensure that you have, is some ability to isolate on a per compute node basis the levels of sensitivity of those applications. And that the reason for that is we're trying to provide a layer of defense in depth in the case of some kind of really significant, serious compromise of the container software itself, of the container runtime. You wouldn't want a model in which somebody running an application, again, at a lower level of privilege, was able to usurp privilege and enter the namespaces of something with a higher level of privilege. And the most effective way to do that isolation is to run those workloads on different compute nodes. Now, that doesn't mean they have to be physically different, but the degree of isolation that a hypervisor provides is much greater than the degree of isolation that the container runtime provides. And so we recommend using hypervisors or virtualization as a completely appropriate way to separate those levels of workload by sensitivity. So it's more about making sure that the host OS environments are different based on sensitivity level, and that can be done, again, per cluster, per node within the cluster by having some sort of affinity or taint for nodes. So there's a variety of ways to do it, but isolating those workloads by sensitivity level is one of the most important recommendations that we make in the special publication. Next, if we go to container countermeasures, some of the things that we recommend there are, again, kind of obvious stuff that you've seen before, which is automatically be able to find and remediate vulnerabilities that you find in that container runtime. I mean, the runtime itself, either Docker or Run C, those runtimes are software themselves. Even though they're very minimal and designed for security as a foremost goal, they still may need to have updates. And so being able to monitor that and enforce that is an important part of the overall security of the stack. Secondly, you want to be able to utilize controls that the operating system already is providing, things like SE Linux and seccomp and so forth, to provide isolation within that host OS and isolation of the host OS from the containers that are running on it. Those are the kinds of capabilities that allow you to have a very strong level of control to ensure that the underlying infrastructure, what's beneath your application, is providing a trustworthy execution environment for the application itself. The second to last bullet you see in the slide here is one of the other things that we think containers really enable you to do for the first time in a practical way, which is to utilize software that does some kind of behavioral learning to profile the applications that you're running within the environment and to automatically prevent anomalies associated with those. This is one of the most important mechanisms that you have to achieve that goal that we talked about earlier, which is how do you deal with the increased scale and ephemeral nature of containers? You can't do that if you require all this manual work and manually configured policies to do so, but you have to rely on software to be able to see these are the things that are normal within this container and to automatically prevent things that are abnormal. And the reason why this really becomes practical for the first time with containers is that the underlying platform has some key differences from previous generations of computing. Containers relative to virtual machines are much more minimalistic. It's a lot less stuff that you're dealing with. They're designed to be much more predictable in nature over time. You're not going to go and update the software in the container. You're going to destroy the container and reprovision a new image. The containers are also more declarative in nature. You're building it from a Docker file. So you've got a more declarative and discoverable way to learn some fundamental aspects about what's normal. And those three attributes, those three differences from traditional systems, really allow you to have an effective and practical way to do this behavioral learning and then to identify anomalies based on what those models predict. And then the final slide we're talking about is the host countermeasures. As part of the stack, you can't ignore what the host OS is doing, because at the end of it, kind of the foundation, if you will, of the entire thing is the operating system that you run those containers on. One of the recommendations we make, and I think one of the most simplistic things that you can do, is to utilize container-specific operating systems for running those, for providing those host operating systems. And those are things like CoreOS, for example. The reason why that's such a useful and relatively attainable way to do this is, if you utilize something like CoreOS, you're going to automatically, by default, have a much more minimalistic, much more streamlined and focused workload operating system that doesn't have all the other potential threat vectors that a more general purpose operating system distribution might have. You're not going to be able to run an email server directly on CoreOS, but you're not going to also have to deal with all the difficulties of configuring and stripping out functionality and hardening it, because it's already designed to do a minimal set of things specifically to run your application containers. We also recommend a few other things on this, but probably the most important one that I would mention here is that you really have to maintain a minimalistic set of file system permissions on your containers. One of the things that's useful for running containers, or at least from a development standpoint, is containers can very easily interact with the host operating system and the host file system. And while that can be friendly and useful from a development standpoint, doing that in production can lead to all kinds of unforeseen consequences and security risks. So you really want to make sure that the containers that you're running have a minimal set of permissions within that host operating system, so you're not exposing the underlying host to threats from a compromised container that it may be running. Dirk, I think you're going to pick up the next section on how we help and Red Hat helps achieve those recommendations in the special publication.
Yes. Thanks, John. So let's talk a little bit more about the details of what we, both Red Hat and Twistlock, can offer to address all the areas, all the items mentioned in the NIST 800-190 doc. And let me just start with the Red Hat side, just to make it a little bit easier. So one of the things NIST that in the special publication is it defines 5 different tiers of a container technology architecture. So it starts with developer systems, which effectively create or generate those images, and then hand over them to the testing and accreditation systems, which validate and verify the content inside, sign them, and finally send them to a registry. The third part is the registry itself, and then the orchestrator and the host, as we just mentioned. So the risk areas are somewhat aligned to this technology architecture. If we just look at the product portfolio we as Red Hat offer, so we have, of course, much more products, but just to highlight the two most relevant in this area, of course, we have OpenShift. Yeah, OpenShift is a comprehensive enterprise-grade application platform built for container workloads. Yeah, so it's the Kubernetes enterprise Kubernetes distribution, and it features a lot of the things called out in the publication. And effectively, it spans across all the 5 areas outlined in the NIST architecture. So we support developer systems with self-service provisioning and consistent environments, with automated build and deploy. We have, or we ship as part of OpenShift, testing and accreditation parts such as CI/CD pipelines. Of course, it's an orchestrator, so it's a Kubernetes distribution, and it has a couple of related features by default. A couple of the recommendations are already enabled by default. We have a network traffic control. It's by default out of the box multi-tenant capable. And the workload separation mentioned in the doc multiple times is one of the elements which works out of the box. And of course, then there's the host section. I will cover a little bit more in a few minutes. But there is a second product which might be relevant in this whole discussion, and this is Red Hat Quay, effectively our enterprise registry offering. And this adds a couple of additional pieces which are not out of the box included in OpenShift, although OpenShift ships an integrated registry. But Red Hat Quay expands the capability, especially on the scanning and signing side, and we are working on a couple of features which are mostly aligned and even motivated by the NIST 800 guide, such as the whitelisting of repositories. It already features today a very comprehensive RBAC and auditing model. So Quay offers a lot of additional features, and effectively those products together provide a huge amount of the capabilities outlined there, but not all of them. And that's the main reason why we have this presentation today, because what I at least realized while reading the NIST 800-190 doc is that we can't address all of the topics and areas mentioned inside. So most of them, many of them, but not all of them. And that's why we are working closely with our partner ecosystem, with our customers, to ensure that we can address all the customer needs, and especially all the needs mentioned in this publication. And this is the main reason, and we will cover a couple of those items in a few minutes, what we as Red Hat and what Twistlock can cover in those areas. So let's quickly talk about one of the key elements in the special application, which is the container host OS. So John already mentioned we have Red Hat CoreOS. It might be a little misleading for the guys who are not familiar with the CoreOS acquisition. So basically, we acquired CoreOS earlier this year, and we made a decision very early the year to merge two existing smaller container-specific host OSs, so Atomic on the Red Hat side and CoreOS Container Linux, and come up with a new name, and the new name is Red Hat CoreOS. Yeah, so Red Hat CoreOS is effectively the new container-specific host OS, which we will start shipping with OpenShift 4.0 coming out soon, which is effectively what NIST describes in the doc. It's a very small, lightweight host, really made to run containers only. It's an immutable host. It's delivered with OpenShift. It has the same release cycle. It's part of the product offering. It's a very minimal, secure OS designed to only run containers. But of course, this still means that customers could still use the traditional Red Hat Enterprise Linux as the underlying host with all its security features, with the tooling around, with the experience in the different operations teams, and all these third-party integrations and certifications we have for Red Hat Enterprise Linux. And then it already starts to add where Twistlock fits in. Twistlock helps us to secure both the host, the platform, the workloads on top of it. So there are multiple things where Twistlock could provide additional value on top of what we as Red Hat ship by default. Another interesting thing in the context of the container host operating system, NIST explicitly calls out, and I like this, and that's why I added this quote here. So you need to keep in mind that even if you have a very lightweight container host OS and it has a very small attack surface, this still means that there is an attack surface. And even those packages, and especially those packages, are typically affected by a security vulnerability. So it's not only having this small and lightweight host operating system, it's also taking care on the update management, especially in the security context. So quickly pushing out security updates for the host operating system. This is one critical element of the mission, and that's what we address with the over-the-air update, originally developed by Red Hat or by CoreOS as part of the Red Hat CoreOS container host OS, which at the same time applies all the updates, bug fixes, and of course CVE remediation via the over-the-air update. You can centrally manage it or within the cluster or outside of the cluster. And the updates are delivered via OCI images, which is another benefit, which effectively means we can store the container host software packages similar to the container workload packages in a registry. And this is pretty powerful. As you probably can imagine, we are working on getting this into Red Hat Quay, that we can ship all the different types of container systems, so both the platform components, the workloads on top of it, and the host offerings within Red Hat Quay. This makes it pretty powerful. John showed one slide around the image-specific countermeasures, and I just want to pick a few of them. We can't cover all of them. So one of the recommendations or key takeaway was to use container-specific tools or technologies for vulnerability compliance and secrets management. So Red Hat Quay features a built-in scanning via Claire, which continuously scans all the images, which means you don't need to pull again or rescan an image if a new vulnerability is coming out, which effectively means the metadata has changed or updated. Then automatically Claire detects it and adds it to the corresponding audit to the affected images. We have a couple of different metadata sources which are used for the scanning itself. Yeah, and this includes, of course, the Red Hat content, so the Red Hat overstream, but it also includes other metadata sources for non-Red Hat content, such as Alpine, Debian, Ubuntu, and stuff like this. But still, it's less than 10 different metadata sources, and we will see on the next slide what Twistlock can add on top of this. One important thing, if we recommend to run one dedicated centralized registry where you do all the governance, all the signing and scanning, and all the policy management and arbing and stuff like this, then scalability and performance, of course, matters. And I believe having the Quay running as the hosted offering called Quay.io, which scales up to millions of images inside, there is no doubt on the scalability of Quay, especially not on the scanning side, because we have seen a couple of other offerings out there, which of course can scan other stuff as well. But the question is, what is the scalability those tools could achieve if it comes to a large customer environment with really hundreds of thousands of images in there? And then probably Quay is a very good choice with the way how we implemented the clear scanning within Quay, that it can scale up to the second largest registry running in the world, which is Quay.io. In addition to the plain scanning itself, so Quay features already today a very powerful notification method, and one of the notifications could be, for example, a webhook, which then would allow you to integrate this into your existing tool chain. For example, create an incident in your incident management system or stuff like this. We are working on a couple of enhancements on the reporting and dashboard side on both Quay and OpenShift. So basically the idea is to bring together the information which is currently stored in Quay for vulnerabilities with the information stored in OpenShift for the runtime itself. So is this image used by any of my pods belonging to which application and belonging to which particular environment? So is it dev only or is it in production as well? And we are bringing together those different information pieces to have enhancements on both sides, on the reporting, dashboarding, and notification side. And then there's another piece we are working on. And again, it's mostly aligned to what has been described in the special publication, doing policy enforcement based on the information captured over the life cycle. And this includes vulnerabilities, this includes signature information, this includes any other type of attestation, so whatever information is relevant, which could be captured in earlier stages of the life cycle. If it's stored in Quay, we can leverage it to do policy management and enforcement on the OpenShift side. So this is a feature we are heavily working on, and hopefully we will be able to release it pretty soon. But let's talk about the additional value Twistlock can bring to it. I'm handing back to John.
Yeah, thanks, Dirk. So some of the things that we do beyond what comes in the base, kind of from the Red Hat standpoint, from the base components, is we try to give people and customers a more contextual view of the information and the vulnerabilities that exist within their environment. So rather than just giving you a list of the CVEs that are present, we give you a view of that information in a way that's unique to your specific environment. So as an example, if you've got a vulnerability that impacts some network component, for example, we know whether or not the containers in your environment are connected to the network, whether or not they have an SE Linux profile associated with them, and a variety of other metrics that we use to give an environmental specific risk score so that the CVEs that are associated with a given image are going to be scored based not just on the base CVSS values within them, but based instead on how those CVSS values impact your particular deployment. And that contextual knowledge allows you to be able to allocate the really scarce resources you have to go and be able to update those images on the things that are of greatest criticality to you. We also have a lot greater upstream data sources than a lot of other providers have, in that we're able to go and look at and utilize over 30 different upstream providers, such that we have more precise information in our results. If you're running an image, on your Core OS host, protected or with OpenShift, and that it's a Java image and it's built on a Red Hat base layer and some Oracle functionality and some Maven packages that you've added to it, within Twistlock, because we have these diverse upstream sources, we'll be able to use a much more precise correlation of data directly from Red Hat to look for vulnerabilities in the base layer, directly from Oracle, for example, to look for vulnerabilities in the JDK. We have custom and oftentimes boutique security research companies that provide us data specifically on vulnerabilities in Maven packages. And what that means for you as a customer is that you have a much lower likelihood of false positives, and the information that you get is more actionable because it's really designed to show you exactly what the vendor who knows that component best thinks about a given vulnerability. And that detection capability that we have spans the entirety of your application's lifecycle. So we can do and detect those problems and actively prevent those problems literally by failing builds from the very beginning of your CI process. So if you're running a tool like Jenkins or really any other CI platform, we have plugins that allow you to look for those vulnerabilities and compliance defects and enforce them from the very first build to whatever registry that you have, all the way into your production environment. You can have a very simple rule, for example, that says, in my OpenShift cluster, prevent running any image that has a high severity CVE. And every time you do a deployment, Twistlock will validate whether or not that image is impacted by the rule, and if so, actually prevent the vulnerable image from running. So Dirk, if you want to progress to the next slide.
Yeah, thanks, Sean. So, and similar to what we just discussed for the vulnerability scanning itself, so the same applies to nearly every other area. So this is just one other example on the registry countermeasures. So basically, some of the recommendations inside the special publications are kind of obvious. So the host can only connect to the registry over encrypted channel. This is kind of obvious. That the request or the access requires out is also kind of obvious. The auditing and logging, so those are features which already exist today or since a long time in Red Hat Quay and other registries offerings as well. And some of the features are, or some of the requirements are not obvious. And luckily, as John said, the NIST publication doesn't explicitly describe how to solve the problem. It basically gives us a lot of recommendation of what we need to address and how we should address, but it still gives us a little bit a degree of freedom on how to really tackle the problem. So one of the examples we discussed back and forth is the automatically pruning or deleting the outdated or stale images within a registry. And basically, for example, we currently envision that we approach it in a slightly different way, that we don't prune or delete them. We just preventing users to access or at least run them, which is effectively, it's achieving the same goal. It's just a different implementation, which is much more efficient in our opinion. And the same applies to other stuff, such as the context-aware authorization control, stuff like this. But again, the key takeaway for the registry, we are aware of the importance of the registry itself in this security context. So one of the key takeaways for us is the registry sits in the middle between all the content and the surrounding metadata on the one hand, and the orchestration platform and the real running workloads on the other hand. So basically, the registry is a very important and critical piece for this whole setup. And this also includes how to get information into the registry, how to store information from different metadata providers. And typically metadata providers are scanners, such as the built-in scanner Claire, or external scanners such as Twistlock. So we started to investigate how can we ensure that we have all the data we need or we want to use on the orchestration side and store them directly in the registry or in the metadata backend used by the registry to have as a holistic view on all the data we want to use or we need to use on the orchestrator side. Just another example, just quickly. So on the image countermeasures, so there is a lot of guidance inside this publication around the untrusted images, and we are aware of the problem. Yeah, so the idea of maintaining whitelists to control what images are allowed to be synced or stored in the registry and then finally used. This is a key item we are working on. The next one is the discrete identification, by its signature. So the whole signature story is a big item. We are actively collaborating with other vendors and working on this feature as well. And of course, the ongoing monitoring and maintenance of the repositories, as we discussed, that we ensure that if an image is no longer updated and then vulnerabilities became applicable to it, that then it's visible. Yeah. So in case you are familiar with the Red Hat Container Catalog and the Container Health Index, so this is what we try to solve with the Container Health Index in the past. that we make it visible what the current state of an image is and how trustworthy at the end of the day an image or a repository and the vendor behind is in this case. And then we added a couple of recommendations for different build stages or different lifecycle stages. So let's start with the build. Yeah, so I already mentioned the container catalog and the health index, which is a good indicator for the first key evaluation or search and evaluate which images you want to use. What are the criteria of those images? What are the characteristics? What's the current security status of those images long before you even pull them? So long before those images are in your environment and stored somewhere. We have a lot of guidance around how to use Red Hat Quay as the centralized content ingress point for all the containerized application, which effectively means let's not bypass the centralized registry that somebody can just pull an arbitrary image from a random store, such as an external registry somewhere as part of the deployment. Let's ensure that every content which is supposed to be deployed on OpenShift and Kubernetes is stored centrally, and then you can apply all the governance models and policy stuff directly in this centralized ingress point. The feature I already mentioned earlier, so an image is automatically scanned immediately after it's getting pushed into the registry. This is part of the Quay-Claire integration, and the build pipeline as part of OpenShift could leverage this information. So both sides have APIs, and we are working on making it easier for customers to integrate those two different things that they can already during a pipeline can double check, okay, the image is pushed in the registry. What's the scan result? Okay, it's not okay. Let's stop here. We don't need to continue there, stuff like this. And of course, we have a lot of tooling or capabilities and features which help you to automate this whole thing and to integrate it better into your existing landscape. And this includes a couple of webhooks, triggers, notifications, and so on and so on. So this is just on the Red Hat side. And of course, we have much more on the, or even more on the Twistlock side. So John, do you want to explain it?
Yeah, absolutely. One of the things that we provide is what we call compliance checks. So our compliance checks take the entirety of the CIS benchmarks for Docker, for Kubernetes, for the Linux host OS itself. They add several dozen checks that our own security research team added as well, and give you the ability to do more than just look for vulnerabilities, but actually look for insecure configurations. We have a template that's built in specifically for the special pub for SP 800-190 that allows you to go and pre-select a section of those checks across all those different sources that's aligned with the guidance that you see in 800-190, so that you can go through and use that template to pre-select the specific things that are aligned with all these recommendations we've made about how to secure your hosts and secure your images and registries and so forth. And those checks are not just simply reactive and monitoring. They're really trying to give you a proactive way to actually prevent insecure configurations. So I mentioned earlier, you can check for them in the build process. You can also check for them at deployment time. So you can say, like, if an image, for example, includes private keys or unencrypted secrets, or it's configured to run as root, prevent all of those things from being able to be run inside your production environment. So we're looking at trying to build on the good stuff that Red Hat has done to provide a great, pure foundational level to be able to provide you some additional capabilities on top of that, focus on making sure that you're taking advantage of all of those configurable options within the OpenShift platform, within the host OS, but also making sure that the applications that you run on top of that are properly configured and don't have things like private keys and other secrets embedded in them. One of the other capabilities that customers often use with Twistlock is the ability to mark certain registries as trustworthy. One of the guidance points that we talked about earlier was ensuring that you're only running trusted images. And with Twistlock, it's very easy to go in and say, only trust images that originate from these registries or these repositories. You can be very specific about what are those trusted sources that you want to allow images to run from throughout your cluster.
Cool. Thank you. And just picking another lifecycle stage. So if I'm finally moving the application I've developed in the earlier stages of the lifecycle to production, then there might be even additional constraints or regulations applicable to the whole stuff. Yeah, so it might be more critical than other environments. So basically, We have a huge amount of different technologies, features, and tools to harden different environments, clusters, separating them, whatever else. So OpenShift has a lot of those features already built into the platform, and you can configure, and we provide a lot of guidance and documentation around it. One of the items we're actively working on is what John just mentioned. So having the policies or policy enforcement components to ensure that production really has the highest level of protection compared with other environments. So while you could do something in dev, we probably want to prevent that you can do the same in production. But this still requires that you have all the information across all those environments. So it's not about bypassing the pipeline or bypassing the scanning for dev. That's obviously not the goal. It's really doing this of environment-specific policy management. And basically, this includes, of course, the policy enforcement based on many different types of attestations. So we mentioned them, signatures, vulnerabilities, any kind of plain text labels or whatever else. And of course, it's important that also the security scanning, this is not a one-time event. So it's not a point of time scanner that the image is scanned during the CI/CD pipeline. This is a continuous vulnerability scanning. So each time a new vulnerability is coming out, automatically it's picked up by CLAIR, the notification could be sent out, and the notification could trigger events of rebuild automation and build automation. And another important aspect, especially for the upcoming OpenShift 4.0 platform, so the Converge platform, the automated operations across the whole stacks makes it easier or much easier for customers to apply this to their existing running platform and all the workloads running on top of it. Because if you can very efficiently manage updates across the entire stack, so starting with the host over the platform and the workloads on top of it based on the operator technology, then you are in a much better shape than you've been before, where you had to do all this manually. So even if you have the information coming out of a scanner or something else, this is not sufficient. So one of the key takeaways, and we had this quote slide at the very beginning of this presentation, is really this only scales if you can automate it. And in addition to the Red Hat tools we provide, Twistlock offers again a couple of valuable add-ons on top of it. John probably wants to say.
So we really provide that modeling capability that we talked about earlier to be able to understand and create this four-dimensional model automatically of all the process activity, network activity, file system, and system calls, and then to automatically look for and prevent anomalies relative to what those models predict. We actually take that model and combine models from multiple entities to also create this connectivity mesh, so that with Twistlock, you actually get what looks very much like a Google map of your environment. You can zoom out and see all the different namespaces you've deployed. You can zoom into those individual namespaces and see the pods, their security posture. You can see what the normal models look like. You can see how they communicate with each other. And then we automatically enforce that layer 3 firewall to provide microsegmentation of the environment. Well, and this slide here really gives you a view of what that looks like. The ability to automatically detect anomalies in the environment and prevent those. We have this view we call Incident Explorer, that when we do find those anomalies, we surface all that information to you in this very usable format so that you can see when an incident occurs, all the information about it, what actually ran, what the checksum of the binary was, what other things that entity talks to. And you can notice there in the middle, this button that you see to view forensics data. One of the cool things that we're doing is always having basically a flight data recorder that's recording all the process and network activity within the containers, but storing it locally on the node and only forwarding into the Twistlock console when there's an actual event, so that it's a very distributed way to collect a lot of detailed forensics data proactively, but without you having to worry about storage and network constraints and impacts that would entail.
And
so Dirk, if you want to go to the next slide.
Yeah.
Yeah, just to summarize some of the key takeaways from the special pub that Twistlock and Red Hat helped jointly deliver. One of the most important ones is again, that organizational people process adaptation, so that you're taking advantage of the automation, that you're able to deal with the changes to scale and the frequency of deployments, to utilize a container host operating system for a smaller attack surface like Red Hat CoreOS, to separate workloads by sensitivity levels, which is, again, something you can do as part of your OpenShift design, using the tools and the processes that take advantage of containers to give you that automated and scalable way of doing security. And that's really where Twistlock comes into play there. And to give you tooling or to use tooling rather, that gives you visibility into the entire stack. So you don't want to have something that just helps you understand the security risk at the container layer, but something that helps you understand the security risks and vulnerability posture and configuration of the host OS and the orchestration tools. And again, we try to build on top of the great work that Red Hat has done to create that foundation and give you that vulnerability management, runtime defense, and compliance, not just for the containers, but also for the host OS that they run on and the orchestration layer that you're using to manage it as well.
And that's also one point I would like to highlight again. So basically, one of the key takeaways for me personally is that after reading this document, I realized, okay, out of the box, we are doing a great job on the Red Hat side on providing most of the capabilities mentioned in there. So we've done a lot of stuff which is mentioned in there, which is great, but not everything. So if for whatever reason you need or you want to be fully aligned and want to have all the guidance implemented, which is mentioned in the documentation, then it's not an or decision. Yeah, it's not about Red Hat or Twistlock. It's really about there is an additional value coming out of our partner offerings. So we've used this as an example to demonstrate you, okay, we have a couple of pieces out of the box. If you want to have the full-blown implementation, then we have partner offerings to close several gaps we won't close in the near future. So this is an additional key takeaway I would like to add here. Yeah. And this brings us to the end of the presentation. Are there any questions?
John, your time today for the information that you shared that was valuable. We have maybe a minute or two for questions for our audience. Chat box is open. We can also have questions come through on the phone line. I do see a couple questions here that I think we'll just want to get teed up out of the gate. One has to do with data protection and the sensitivity of data. How do you guys ensure that the data is protected? Is it a hosted service, or how does this work in terms of ensuring my data is protected?
Well, from the Twistlock standpoint, Twistlock is just a cloud-native app. So we give it to you as a set of images, and you deploy them onto OpenShift as any sort of like OpenShift application. So you run it as a replication controller and deploy the Twistlock Defender to your nodes as a daemon set. So your data is completely under your control at all times. It's not a SaaS service. Twistlock never sees your logs or your images or anything else. You run it wherever you run OpenShift. It could be any cloud, could be a hybrid cloud. Your data is completely private to you at all times.
And the same applies for OpenShift. And there's one additional thing. So on the OpenShift side, we ship by default a couple of different storage options, and we have a couple of different underlying storage options for you, which might help you to address some additional data privacy concerns as well. Yeah, so it's entirely up to you. So it's your responsibility. Yeah? So there's nothing stored outside or shared with somebody.
Okay, just for frame of reference, guys, how do customers get started? Is this a small deployment with a development team that is potentially trying to scan and protect some tier 2 images? How do customers still get started? How do they scale?
So basically, what we are doing together is we are running workshops with different customers. We have typically we already have today joint customers which haven't been able to bring those two different pieces together. But they started to look at us and basically ask us, okay, could you help us implementing a more efficient and scalable approach for security? And then we start to review what the current state is and where they would like to go and what are the requirements and stuff like this. And then we talk about all the options. And typically, I'm using this NIST 800-190 on a regular basis to explain, okay, this is a huge set of options, and it's up to you to pick all of them or some of them. And then we talk about, okay, what are the options within all those different areas? And then typically we are working closely together with Twistlock and other partners to bring them into the customer conversations and finally come up with an implementation roadmap. What does it mean, and how could we integrate all those different pieces?
Excellent. Well, we've reached the top of the hour, and I want to thank both John Morello, the CTO of Twistlock, and Dirk Herrmann from Red Hat for their time today. Thanks for the information shared. We will post this recording for future viewing, and we want to thank the audience for attending today. Thank you, everyone.
All right, guys, well done. That was awesome content, and I'm looking forward to getting the slides and watching this again with a better bandwidth on my part. So thank you very much for taking the time, John and Dirk. And we'll if you could send me the slides, that would be great.